Hello guys, I am Ankit. In this video, we shall see another problem on LeetCode, flood field. So they have a matrix represented by cross-sum with the elements in that. And our task is we have to do the flood fill. What do you mean by flood fill? You have to perform a flood fill in the on the image, starting from the pixel, whatever image of starting row and starting column index they have given. So flood fill means we have to consider the starting pixel. Starting pixel is nothing but SR comma SC is 1 comma 1. So starting row is 1, starting column is 1. So that is this position. So we have to start from there considering the starting pixel plus any pixels connected to 4 directionally to the starting pixel of the same color as the starting pixel. That means up, down, left and right, up, down, left and right. You have to check whether if the color, if here color mean indicates the number, if 1 is equal to 1 here, here also 1 is equal to 1, here 1 is not equal to 0, 1 is not equal to 0. If their color is matching, the number is matching, and yeah, then you have to replace that color with the new color. So you start with this one. Okay, you start with this one, you check whether this one is equal to the new color. No, update it to 2. Now look upward, it is not also not equal to 1. Update it to 2. So once you update this to 2, again you have to look in this particular cell, top, bottom, left and right. So basically it's a depth first search what we'll be implementing here. So I'll explain this logic. So the condition what they tell is we start from the pixel. Okay, we have a color that is 2 here, and let the original color is nothing but starting pixel, starting row and starting column given here is 1. So 1 comma 1, that is 1, right? So original color will be 1 here. That is nothing but matrix of 1 comma 1. So 1. So first what we need to tell is that what the problem tells is first we have to check whether this original color is equal to the given color, new color. Is it equal? No, 1 is not equal to 2. That means update this to 2. Okay, this becomes 2 now. So once you update this to 2, now look into the cells above, below, left and right. Above, below, left and right. And perform the same operation then. But perform the same operation there only if the condition is you first look above. Recursively call the function. You could look above. Check whether the value in this position equal to the original color. Original color means original color in the sense starting pixel. So starting pixel color is 1, and the value and the color in this cell also is 1. So that means they're matching. Only then update this to 2. Okay. Only then call the function. So now we are done here. So next recursively call here also again up. Since we update the value again up, down, left and right. So I'm going in the order up, then down, left, right. The recursive call is happening in this manner. Okay. So we moved from here to up. Again in this we are moving up. So this is out of range index is. Okay, then that will stop here. So once up is done, we have to move to down. So now the value is down is 2. But if you see this 2 is already equal to the new color. It is not equal to original color. Only if it is equal to original color, you update it to new color. So but it is already new color, you will not be updating anything. Okay then. So down is done. Now what we need to do? We have to move to left. So if you move to left again 1. 1 is equal to the original color, whatever we had, the starting pixel. Yes. So update is 2. So update is 2 and again recursively call. Up, down, left and right. So you might ask, how are you telling you're going left, right? How will you get to know? That's why I'm telling this order. Keep this in mind. So from here, move down. Again, move. No, not moving down. From here, we moved up. You know, up we found, not there. Down we found. Done. So now we are moving left here. So in this cell, first we have to move up. No, not there. Out of range. Down. Again check. After up, you have to check down. So down you have 1, which is equal to original color. Yes, update it to 2. Now again recursively call. Once updating, recursively call. Up, down, left and right. So okay. So first we have to check up here, recursive call. So up is already 2, which is not equal to original color. Don't do anything. Now check down. Again 1, which is equal to original color. So update this to 2 and recursively call here also. Up, down, left and right. So here up is done. Okay, up we have to check now. So it is equal to 2. New color, you need not to change anything. Down, you check it is out of range. Left check, it is out of range. Right, if we check 0. Do we need to update this to 2? No. Why? Because this is not equal to original color. Original color was 1 at the starting pixel, which is not equal to this color 0. So you don't do anything on this. Will not update it to 2 and do the recursive call in this cell. Got it? So that's why I have told. We change only if it is equal to original color. If it is equal to original color, update that particular color to 2 and do the recursive call to the neighboring cells. Neighboring cells in the sense up, down, left and right. So you will not be doing. So here for this cell, up is done, down is done, left is done, right is done. So you have where we had come from this above cell, right? So in this above cell, down is done. Now up is done, down is done. So once down is finished, this down is finished. So this down has been finished. Okay, it's not visible. So this down has been finished. Now after done, what we have to look? Left, right. So look here, left, not there. Now look for right. Right is already 2, which is equal to new color. So need not to do any recursive call here. So here again you move back now. So again for this, down is done. We have to move after down, left. Left is not there. Right, right is 2, which is already the new color. So need not to do anything. So once you come back again here. So in this cell, so we moved up, down, left is done because you moved we came back from this cell, no? So left is done. Now you have to look for this right. So here again you could see this is 1, which is equal to original color. That's why we update it to 2 and do the recursive call. Up, down, left, right. Only if it is equal to original color, only then we look for the neighboring cells, the recursive call. So that will be up. Now here again check up. No, it's invalid index. So down 0, which is not equal to original color. So we'll not do anything. We'll not do any recursive call or update the color also. Then you look for left, which is already 2, so need not do anything. Right, it's out of range. Okay, so you came back from here also. So now you came back from here, you move down. So again, in this, you have finished all the recursive calls from this. So you could see updated is 2 here, 2 here, 2 here, 2, 2, 2, then 0, 0, 1. So which is equal to the resultant matrix. So this is how we do the depth first search. So basically what we do at the beginning, if in case instead of 1 here, instead of 1, the same matrix has 0 in the sense. So this 0, then this 0 will be the original color. So recursively when you call here up down, this all will be 1, will not do anything. Only here and here it will get changed. You first you call down, then left and then right. So down will be here we call the recursive. So like this. First you check whether the original color is equal to new color. But if in case, let's say, instead of 1 we had 2 here. So original color will become 2 and the new color is 2. Original color is equal to 2 and new color is also 2. That means original color is equal to new color already. Do we need to do any updation? No. If you do not do update it to the new color, then you will not be having any recursive calls. All these recursive calls get stopped. So we'll be returning the original matrix itself. So if we have 2 here, this 2 is equal to new color, will not do updation, will not do a recursive call. Recursive call in the sense will not looking for the neighboring cells up, down, left and right. So they will return the original matrix. So first check that. If it is equal, not do anything. If it is not equal, update it, do the recursive call. And in the neighboring cells also, how do we update the values? Only if it is equal to the original color. Then do update it to the new value. So we will implement this. So for that, what we can do is, I'll implement the logic here. Okay. So first, let's define the row. How much is the value? So that will be image dot size, and then we'll define the columns. Let this be one of the rows dot size. Now we'll compute the original color. So original color equal to starting row, starting column, the value at that position. So image of starting row, comma, starting column. So now in the beginning, what we need to do? So we need to look if, So in the beginning, we need to look if original color is equal to color. If it is not equal to color, if it is equal to color, then you will not do anything. Just return the exact image. If it is not equal to color, then what we need to do? So in that case, image of SR comma SC will be equal to the new color, and then do the recursive call TFS of. So in this parameter should be the image, then starting row, starting column, then row size, column size. Why row size and column size required? Because when you go out of bound, you need to get that condition. That's why. Then let's pass the original color and new color also, that is color. So at the end you return the image. So if here only the condition doesn't satisfy, you need not to go in this if condition. You return directly original matrix. Otherwise you do the if TFS. So now let's write the TFS function. Vector will not return anything. No? So write it as void DFS of. So I'll copy this and paste it. Image, source, starting row, starting column. Then next in rows, in column. After that, in original color, comma, we can say this as new color. Let's rename the new color. So in the beginning, we will write the base condition. What is the base condition? That will write it later. So we'll do the recursive call first, up, down, left, and right. No, or else we can write the base condition. What will be the base condition? So one base condition, the size out of range. So if it is goes out of range, then just return whenever you are in this position, this position, this position, this position. So out of range. Other will be whenever you are calling the recursive call, only if the value in this position is not is equal to original color, only then you are updating it to new color. So the base condition first should be um, we are passing okay rows column starting row starting column. So starting row should be greater than 0 and or no, that will be the correct condition. It should be if it is less than 0 instead of starting to starting column, let's say it's row comma column. Every time it won't be the starting one, no, so that's why. Yeah, so if row is less than 0 or row is greater than or equal to rows the size, or column is less than 0 or column is greater than or equal to column size, or the last thing will be if original color is not equal to new color, then we just return, will not do the recursive call, right? Out of range, and here if you see 0, it is not equal to new original color 1, so we'll not do the recursive call in this case and update it to 2 also. So we just return. Otherwise what we need to do, if here one we encounter it is equal to the original color, so we have to update it to 2, no? So the image of row comma column will be equal to new color. So here we need not to do actually, because if it is not equal, just directly call the DFS. Initially the condition won't satisfy, so image of row color column 1 comma 1 will be updated to new color. Then call the DFS of 4 indices. So this should be row and here it should be column. I'll put the bracket. So first will be nothing but row minus 1 we do. I'll copy it 4 times. Yeah. So first will be row minus 1, then it will be row plus 1 below. Left is nothing but column minus 1. and right is will be column plus 1. Yeah, that's it. So first we check original color equal to new color. If it is not equal only, then we call the recursive function. In that recursive function, first you update the values, then recursively call up, down, left and right. In up also, you check for this condition. And in the other cells also, you have to check whether original color is not equal to new color. Only then what we do the recursive calls. That is the base condition and we return the answer. So we will run this. Hope this works. Um, okay. So yeah, this should be new color. Now we will run this. Okay, second test case is not passing. 0, 0, 0. Let's okay. First test case is not passing. Let's go through the code once. This is okay. Original color you take. You call a recursive function base case 0, 0. Yeah. So we are not comparing original color is not equal to new color every time. We have to look image of row comma column. No? If that value is not equal to original color, so image of row comma column. So if image of row comma column, so in the element at this position, if it is not equal to original color, then you return. Because in this case 0, this is not equal to 1. So you return. I don't know why did I write that. Okay, yeah. Now let's see. Yes. So we'll see the Java logic also. Same thing applies here, nothing change much. So we'll submit this. Yes, successfully submitted. If you understood the concept, please do like the video and subscribe to the channel. We'll come with other video in the next session. Until then, keep learning. Thank you.